when working with quotients and exponents, it's going to be similar to the way that we worked with products and exponents, only this time instead of adding and multiplying exponents, we will be subtracting them. So anytime you divide bases that are the same, we're going to be subtracting the exponents. Let's take a look at example 1a. We have a to the 6th divided by a to the 14th. The rule says when we divide, we're going to be subtracting. So we take our top exponent, a to the 6th, and we're going to subtract the bottom exponent from it. So we're doing 6 minus 14, which is negative 8. And as we saw before with a previous video, when you have negative exponents, you have to keep going to make it simplified, and this is going to turn into a fraction, 1 over a to the positive 8. And that'll be our answer. For the B example, we have two common bases. So let's start with the C. We'll start with the top exponent. It's the negative 1. And we're going to subtract the 5 that's on the bottom from this. So we have c to the negative 1 minus 5. Our D will be 3 minus negative 4. So we always start with the top exponent and subtract the bottom one from it. Let's evaluate. C's exponent is going to be negative 6, and D's exponent will be positive 7. Since C has a negative exponent, we're going to have to simplify further. So it'll drop down into the denominator and turn positive. And D, since it's already a positive 7, it's going to remain where it's at and stay in the numerator. So that's pretty simple. Let's look what happens when we have quotients that are being raised to a power. So in this case, our example 2 and 3, we now have fractions that are being raised to exponents. And the first thing that we need to do is just understand what that means. This is talking about 4 over x squared cubed. So an easy way to think about this is you're taking the numerator and raising it to the power that's outside. So that's going to be 4 to the 3rd, and the denominator will be x squared raised to the 3rd power. 4 to the 3rd power is 64. And on the bottom, since I'm now raising a power to the power, just like in the last video that we saw, that's going to be multiplication. So we'll do 2 times 3 is 6. And that is as simplified as we can make example 2. So when you've got a quotient that's being raised to an exponent on the outside of the parentheses, you're basically applying that exponent to everything that's inside on top and on bottom. In example 3, it's basically the same, only this time you can see that we have a negative 2 instead of a positive 2. And what that means is it's going to turn our fraction into a compound fraction that'll look similar to this. And we've done an example like this in the past where we had a fraction and a fraction. And just to kind of give you a shortcut of that, rather than having to divide all this out and doing it this way, because this is basically what this compound fraction means, is 1 divided by 3/5 squared. Instead of doing all of this, we can take a shortcut, because when you raise a fraction to a negative exponent, basically what it wants you to do is flip the fraction and then make it positive. And that negates having to do all this extra work over here, because this would be the keep, change, flip method, and when we'd end up flipping it anyway, and that's a lot of extra work. So we'll just skip straight to flipping it and making it positive. And from there we follow the same thing that we did for example 2. So this is going to be 5 squared over 3 squared. 5 squared is 25. 3 squared is 9. And since that will not reduce, we'll leave it 25 over 9. If you have any questions, make sure that you're asking class.